Now, in this lecture, we will find out the radius of the biggest circle. In the drawing, we have 4 circles. Those 3 circles are inside the biggest circle. We know that the radius of this circle is equal to 4 units. The radius of this circle is equal to 9 units. The radius of the smallest circle is equal to 1 unit. And we want to find out the radius of the biggest circle. So, first of all, I'll present to you 2 new terms. When 2 circles are tangent to each other, there are 2 types of tangency. The first type of tangency between 2 circles is the external lunge. The external lunge is when the 2 circles are touching each other externally. Like in this drawing, those 2 circles are touching each other or are tangent to each other at point S, this point. And in this case, the distance between their centers is the sum of the lengths of their radii. Here we know that the center of the small circle, this circle is at point M, and the radius of the small circle is equal to small r. The center of the big circle is at this point, point O, and the radius of the big circle is capital R, is equal to capital R. And the distance between their centers, that is to say MO is equal to the sum of the lengths of their radii, that is to say it equals to capital R plus small r. I'll repeat again, whenever 2 circles are touching each other externally, then the definition of this situation is external lunge, and the distance between their centers will be equal to the sum of the lengths of their radii. In this case, OM, the distance between their centers, will be equal to capital R plus small r. So the external lunge is the first type of tangency between 2 circles, or the first way that 2 circles can touch each other at one point. And the second type of tangency between 2 circles is the internal lunge. Here the 2 circles are touching each other internally at this point, point S, and the distance between their centers, that is to say OM, is equal to the difference between the lengths of their radii. Okay, in this case, the distance between the centers, that is to say OM, equals to OS minus SM. And OS is equal to capital R, and SM equals to small r. Therefore, the distance OM between the centers of those 2 circles is equal to capital R minus small r. So in conclusion, we can say that whenever 2 circles are touching each other internally, then the distance between the centers is equal to the difference between the lengths of the radii. In this case is capital R minus small r, while if2 and uh, the term in this case is that they have internal lunch between them, while if two circles are touching each other externally, that is the external lunch, then the distance between their centers will be equal to the sum of the lengths of their radii. In this case it will be equal to capital R plus small r. Okay? So here we will define the center of this circle as point A. We will define the center of this circle as point B, and we will define the center of this circle as point C. Here we know that this straight line is tangent to those three circles at 3 points. Here the straight line is tangent to this circle at this point. This is the point of tangency. We define this point, the point of tangency, as point D. So I write down that point D is the point of tangency between this tangent of this straight line with this circle. Likewise, this point is the point of tangency if the straight line and this circle. We define this point as point E. So E is also the point of tangency between this straight line and this circle, and here we will define the touching point between the straight line and the smallest circle as point F. Point F is also the point of tangency of this tangent of this straight line with this small circle. So actually, points E, F, and D are the point of tangencies of the straight line with those three circles. In the next step, we will join points A and D together by a straight line. Here actually A is the center of the circle, so AD is the radius of this circle. That is to say, it equals to 4 units. It is given as the question that the radius of this circle is equal to 4 units. Why line segment AD is the radius of this circle? Because of the fact that it starts from the center of the circle, that is to say, line segment AD starts from point A and ends at point D, that is a point on this circle itself. Therefore, AD is the radius of this circle, that is to say, it equals to 4 units. Likewise, we will join points B and E together by a straight line. here EB is the radius of this circle because of the fact that it starts from point B, that is the center of this circle, and ends at point E, that is a point on this circle itself. Therefore, EB is the radius of this circle, that is to say, it equals to 9 units. So we can write here that EB equals to 9 units. Is the radius of this circle that equals to 9 units. Likewise, we will join points C and F together by a straight line. Here, CF is the radius of the smallest circle, that is to say, CF equals to 1 unit, because the radius of the smallest circle equals to 1 unit. In the next step, I will present to you a new rule that is actually rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. I will read rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have the radius AD is drawn to the point of tendency, that is to say, it is drawn to point D, that is the point of tendency of this tangent with this circle. Therefore, the tangent FD will be perpendicular to the radius AD. This radius, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we have the radius BE, the radius of this circle, that is drawn to the point of tendency. That is to say, it is drawn to point E, that is the point of tendency of this tangent with this circle. Therefore, the tangent DF will be perpendicular to the radius EB. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we have the radius CF that is drawn to the point of tendency. That is to say, it is drawn to point F, that is the point of tendency of this tangent DF with this circle. Therefore, the tangent DF will be perpendicular to the radius CF, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Here we will define the center of the biggest circle as point O, and so the center of the biggest circle is defined as point O, and we will define the radius of the biggest circle as capital R. So I write it here that capital R is the radius of the biggest circle. The radius of this circle, the radius of the biggest circle. In the next step, from point A, we will draw perpendicular to BE. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We will define the touching point between the perpendicular from point A and BE as point P, and we will focus on quadrilateral AFDE. Here in quadrilateral AFDE, we have three right angles, 1, 2, 3, and the sum of three right angles is equal to 90 times 3 is 270 degrees, plus the size of this angle, that is actually angle DAP, In total, the sum of those four angles, they must be equal in total to 360 degrees. Okay. Here we will subtract 270 degrees from this equation, and we will get that the size of angle DAP is equal actually to 360 degrees minus 270 degrees is actually equals to 90 degrees. So angle DAP is a right angle. It equals to 90 degrees. So we can write here that angle DAP is a right angle. So because of the fact that angle DAP is a right angle, then quadrilateral APDE has four right angles, and any quadrilateral that has four right angles, it must be a rectangle. So we can write down that quadrilateral AFDE is a rectangle. Quadrilateral AFDE is a rectangle. So we can write here quadrilateral AFDE is a rectangle. So, and we know that the opposite sides of a rectangle are equal to each other. Write it down. The opposite sides of a rectangle are equal to each other. So here it was in rectangle, naturally rectangle APDE. In rectangle APDE, the opposite sides are equal to each other. That is to say, AD equals to PE. AD equals to PE. According to the rule that the opposite sides of a rectangle are equal to each other. But we know that AD equals to 4 units. It is the radius of this circle. AD equals to 4 units. So from this equation, 4 equals to AD equals to PE. We will conclude that PE is also equal to 4 units. Side PE is also equal to 4 units. Here side PE equals to 4 units. And what is the value of line segment BE? The value of line segment the value of line segment BP. The value of line segment BP is actually equals to BE minus PE. BE minus PE is equal to BP. Again, the value of line segment BP is equals actually to BE minus PE. So BP equals to BE, that is actually 9 units, minus BP, that is minus PE, that is equal to 4 units. So BP equals to 9 minus 4, that is to say it equals to 5 units. So we found out that BP equals to 5 units. In the next step, from point O, we will draw perpendicular to DE. So this angle is equal to 90 degrees, and this angle will be also equal to 90 degrees, and we will define the touching point between the perpendicular from point O and DE is point M. This point will be defined as point M. We will focus on quadrilateral, and we will actually define the intersection point between the perpendicular from point O and AP as point S. In the next step, we will focus on quadrilateral ASDM. In quadrilateral ASDM, this quadrilateral we have 3 right angles, 1, 2, 3. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this angle, that is actually angle ASM. In total, the sum of those 4 angles must be equal to 360 degrees. I repeat again, 270 degrees plus the size of angle ASM. In total, they must be equal to 360 degrees. We subtract 270 degrees from this equation, and we get that the size of angle ASM is equal to 360 degrees minus 270 degrees is equal to 90 degrees. So this angle ASM, is a right angle. It equals to 90 degrees. Likewise, we focus on quadrilateral SPME. In quadrilateral, but before that, because of the fact that this angle is a right angle, so quadrilateral ASDM has 4 right angles. That is to say, quadrilateral ASDM is a rectangle. Okay, so we can write down that this quadrilateral ASDM is a rectangle So actually we found out that this quadrilateral ASDM is a rectangle. Likewise, we'll focus on quadrilateral SPME, this quadrilateral SPME has 1, 2, 3 right angles, and the sum of three right angles is equal to 270 degrees. 270 degrees plus angle PSM, this angle, in total the sum of those four angles, they must be equal in total to 360 degrees. That is to say, 270 degrees plus the size of angle PSM, in total they must be equal to 360 degrees. We will subtract 270 degrees from this equation, and we will get that the size of angle PSM is equal to 360 degrees on 270 degrees. It is equals to 90 degrees. Angle PSM is a right angle. Again, quadrilateral PSM has four right angles. Therefore, quadrilateral PSM, this quadrilateral SPME, quadrilateral SPME is a rectangle. Okay, so quadrilateral SPME is a rectangle, so we actually found out that we have here three rectangles. Quadrilateral APDE is a rectangle, quadrilateral ASDM is a rectangle, and quadrilateral SPME is also a rectangle. Here we have from point O we draw perpendicular to DE, so OM is a perpendicular, it is absolutely a straight line. So we can write down that line segment OM is a straight line. Again, line segment OM is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line OM at point S, then the sum of the angles on this side at point S, the sum of the angles must be equal to 180 degrees. So which angles we have at this side at point S? We have here 90 degrees plus angle OSA in total. The sum of those two angles must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles on one side of a straight line is equal to 180 degrees. So 90 degrees plus the size of angle OSA. In total they must be equal to 180 degrees. We will subtract 90 degrees from this equation and we will get that angle OSA is equal to 180 degrees minus 90 degrees. It is equal to 90 degrees. So angle OSA is a right angle here. Angle OSA is a right angle, so this angle OSA equals to 90 degrees. In the next step, we will join points A and B together by a straight line. So what is the value of line segment AB? The value of AB, A is the center of this circle that its radius is equal to 4 units. B is the center of this circle that its radius is equal to 9 units. And those two circles have an external length between them, that is to say they are touching each other externally at this point. This is the point of tendency. And whenever you have two circles that have an external length between them, then the distance between their centers, that is to say AB, will be equal to the sum of the lengths of the radii. That is to say, AB will be equal to the radius of this circle that is 4 units, plus the radius of this circle that is 9 units. 4 plus 9 is 13. So we found out that AB equals to 13 units. AB equals to 13 units. So in the next step we will focus on the right triangle ABP. On the right triangle ABP, according to the Pythagoras theorem, here the letters P and T is abbreviation for Pythagoras theorem. So according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of the right triangle ABP is AB, so the square of the hypotenuse is AB squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say, it must be equal to BP squared plus AP squared. So in conclusion, we found out that according to the Pythagoras theorem, in the right triangle ABP, AB squared must be equal to BP squared plus AP squared. AB equals to 13 units, so AB square is 13 square. 13 square is 169 equals to BP square. BP equals to 5 units, so BP square is 25, because 5 square is 25, plus AP square so here we found out that 169 equals to 25 plus AP square. Here we subtract 25 from this equation and we get that 169 minus 25 is 144. So we found out that AP square equals to 144. We'll take a root out of this equation and we'll find out that AP equals to the square root of 144, and the square root of 144 is 12. So we found out that AP equals to 12 units. So we can write here that AP equals to 12 units. AP equals to 12 units. And we have already found out that quadrilateral APDE is a rectangle. So in rectangle APDE, the opposite sides are equal to each other. That is to say, AP equals to DE. Again, in rectangle APDE, the opposite sides are equal to each other. That is to say, AP equals to DE. But we just right now found out that AP equals to 12 units. So we can write here that AP equals to 12 units. And from this equation, 12 equals to AP equals to DE, we will conclude that DE is also equals to 12 units. Okay, so we can write here that DE is also equals to 12 units. In the next step, we'll define line segment ME. This line segment is X. So we define line segment ME as X. So ME is equal to X according to our definition. So we can write down that ME equals to X. And because of the fact that quadrilateral SPME is a rectangle, we already found out that quadrilateral SPME is a rectangle and the opposite sides of a rectangle are equal to each other. That is to say, ME equals to SP. Again, in rectangle SPME, here in rectangle SPME, ME equals to SP, but according to our definition, ME is equal to X. So from this equation, X equals to ME equals to SP, we will conclude that SP is also equals to X. SP also equals to X. So what is the value of line segment DM? The value of line segment DM here, DM equals to DE minus ME. Again, DE minus ME equals to DM. So it equals to DE minus ME. And repeat again, DM equals to DE minus ME. So actually DM equals to DE, that is 12 units, minus ME, that is equal to X according to our definition. So in conclusion, we found out that DM is equal to 12 minus X. So we can write here that DM is equal to 12 minus X. And again, we know that ASDM is a rectangle. So in rectangle, ASDM here in this rectangle, rectangle ASDM, the opposite sides are equal to each other. That is to say, DM is equal to AS. Again, in rectangle ASDM, DM is equal to AS. but we know, we already found out that dm equals to 12 minus x. So we can write here that dm equals to 12 minus x. And from this equation, 12 minus x equals to dm equals to as, we conclude that as is also equals to 12 minus x. So we can write here that as is equal to 12 minus x, and what is the value of line segment AO? The value of line segment AO, first of all, we know that A is the center of this circle, that its radius is equal to 4 units. O is the center of the biggest circle, that its radius is equal to capital R. And this circle and the biggest circle have an internal length between them at this point, that is to say they are touching each other internally at this point. And whenever two circles are touching each other internally, then the distance between their centers, that is to say AO, will be equal to the difference between the radius, the difference between the lengths of their radii. And the radius of this circle is equal to 4 units. The radius of the biggest circle is equal to capital R. And the difference between those radii, it will be equal to R minus 4. So we found out that AO equals to R minus 4. In the next step, I will copy the right triangle AOS in a new page, and we will implement the Pythagoras theorem on this right triangle. Okay, so here we have the hypotenuse AO that equals to R minus 4. But before that, In rectangle ASDM, in this rectangle, the opposite sides are equal to each other. In rectangle ASDM, the opposite sides are equal to each other. That is to say, AD equals to SM, AD equals to SM. Again, in this rectangle ASDM, we know that AD equals to SM, but AD is the radius of this circle, that is to say it equals to 4 units. So we can write here that AD is the radius of the circle is equal to 4 units. So from this equation 4 equals to AD equals to SM, we conclude that SM is also equals to 4 units. So SM equals to 4 units. So here this is the right triangle AOS. What is the value of OS? The value of OS is equal to OM minus SM. Here we will define OM as Y. So OM is equal to Y according to our definition. And we know that OS is equal to OM minus SM. OS equals to OM minus SM. So OS is equal to OM, that is Y according to our definition, minus SM, that equals to 4. So in conclusion, we found out that OS equals to Y minus 4. Here we can write down that OS equals to Y minus 4. And now we can implement the Pythagoras theorem on this right green triangle OAS. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle OAS, according to the Pythagoras theorem, we will get that AO square equals to OS square plus AS square. So here OA is equal to R minus 4, so OS square will be equal to R minus 4 square, and it is equal to OS square. OS is y minus 4, so OS square will be equal to y minus 4 square plus AS square. AS equals to 12 minus x, so AS square will be equal to 12 minus x square. So in conclusion, we found out that according to equation number 1, r minus 4 square equals to y minus 4 square plus 12 minus x square. So here we'll open the brackets on both sides of equation number 1, and we will get that according to equation number 1, r minus 4 square is equal to r square plus 16 plus a minus 8r, and it equals to y minus 4 square y minus 4 square equals to y square plus 16 minus 8y plus x 12 minus x square is equal to 12 square, that is 144, plus x square minus 24x. So here we have 16 on both sides of equation number 1, so 16 will get cancelled. We will add 8r to this equation number 1, and we will get that according to equation number 1, r square equals to 8r minus 8y plus 144 minus 24x. Plus x square plus y square. Here we subtract x square and also y square from this equation, equation number 1, and we will get that as r square minus x square minus y square is equal to Here we have 8r minus 8y, so we'll take 8, we'll take out 8 as a common factor out of those two expressions, and we'll have here inside the brackets r minus y plus 144 minus 24x. So, in conclusion, we found out that according to equation number 1, r squared minus x squared minus y squared equals to 8 times r minus y minus, it is actually plus 144 minus 24x. Okay. In the next step, from point O, we will draw perpendicular to BE. From point O, we will draw perpendicular to BE. So this angle will be a right angle, and this angle will be also a right angle, and we will define the touching point of the perpendicular from point O to BE as point T. So here I will copy the right triangle OBT in a new page, and we'll implement the Pythagoras theorem on this right triangle. So we add this right triangle. So we will implement the Pythagoras theorem on the right triangle OBT. But first of all, I will copy this right triangle in a new page. the triangle OBT is the green right triangle. According to our definition, OM equals to Y. I'll write it again, OM equals to Y. And here in quadrilateral OTME we have three right angles, 1, 2, 3. The sum of three right angles is 270 degrees plus the side of this angle that is actually angle MOT. In total, the sum of those four angles, they must be equal to 360 degrees. We'll subtract 270 degrees from this equation and we'll get that angle MOT is equal to 90 degrees. So this angle is the right angle, therefore quadrilateral MOTE is a rectangle and we know that the opposite sides of a rectangle are equal to each other. That is to say, OM is equal to TE. OM equals to TE. But OM equals to Y according to our definition. So from this equation, we will conclude that TE is also equals to Y. TE equals to Y. Here TE equals to Y. Likewise, ME must be equal to OT. ME must be equal to OT. But ME equals to X according to our definition. ME equals to X, so from this equation X equals to ME equals to OT, we conclude that OT is also equals to X. OT is also equals to X. We know that BE is the radius of the circle that equals to 9 units. Here PE is the radius of the circle that equals to 9 units. And TE equals to Y. So what is the value of BT? You can see it easily from the drawing that BT is equals to BE minus TE. It equals to BE minus TE. That is to say BT equals to BE, that is 9 units, minus TE, that is Y. So we found out that in conclusion that BT equals to 9 minus Y. What is the value of OB? O is the center of the biggest circle that its radius is equal to capital R. B is the center of this circle that its radius is equal to 9. The biggest circle and this circle have an internal notch between them at this point, that is to say they are touching each other internally at this point, and therefore whenever you have two circles with an internal length between them, then the distance between their centers, that is to say OB, will be equal to the difference between the lengths of their radii. That is to say, in this case, it will be equal to the radius of the big circle that is actually capital R minus the radius of this circle that is 9. That is to say, OB equals to R minus 9. So you can write here that OB equals to R minus 9. So now we can implement the Pythagoras theorem on this right green triangle, triangle OBT. So in the right green triangle, triangle OBT, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is OB, so the square of the hypotenuse is OB squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to BT squared plus OT squared. So here, OB equals to R minus 9, so OB squared is R minus 9 squared. Equals to BT squared. BT equals to 9 minus y, so BT squared will be equal to 9 minus y squared plus OT squared. OT equals to x, so OT squared will be equal to x squared. So in conclusion, we found out that according to equation number 2 in triangle OBT, R minus 9 squared equals to 9 minus y squared plus x squared. Here we will open the brackets on both sides of equation number 2, and we will get that R minus 9 squared equals to R squared plus 81 minus 18R, that equals to 9 minus y squared. 9 minus y squared equals to 81 plus y squared minus 18y plus x squared. So here in equation number 2 we have 81 on both sides of the equation, so 81 will get cancelled. We will add 18 out to this equation, equation number 2. And we will get that R squared equals to 18R minus 18y plus x squared plus y squared. Here we will take 18 as a common factor out of those two expressions, and we get that according to equation number 2, R squared equals to 18 R minus y plus x squared plus y squared. So here we'll subtract x squared and y squared from this equation, equation number 1, and we get that according to equation number 1, equation number 2, according to equation number 2, r squared minus x squared minus y squared equals to 18 times r minus y. Again, according to equation number 2, we found out that r squared minus x squared minus y squared equals to 18 times r minus y. In the next step, from point C, we will do a perpendicular to BE. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. We will define the touching point between the perpendicular from point C to BE as point Q. So in quadrilateral QCEF, we have 3 right angles, 1, 2, 3. The sum of 3 right angles is 270 degrees, plus the size of the fourth angle, that is actually angle QCF. In total, they must be equal to 360 degrees. Here we will subtract 270 degrees from this equation, and we get that the size of angle QCF is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. So actually we found out that quadrilateral QCEF has 4 right angles, therefore quadrilateral QCEF is a rectangle I'll repeat again. Quadrilateral QCEF is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, CF is equal to QE. CF is equal to QE. CF is equal to QE. But we know that CF equals to 1 unit. It is the radius of the smallest circle. So from this equation, we conclude that QE is also equals to 1 unit. QE is also equal to 1 unit. So I can write here that QE is equal to 1 unit. In the next step, We will join points P and C together by a straight line. And we will implement the Pythagoras theorem on the right triangle, triangle BQC. But first of all, we will find out the value of line segment BC. What is the value of line segment BC? BC is actually the distance between the centers of the smallest circle and the center of this circle that is radius is 9 units. So those two circles, the smallest circle and this circle, have an external notch between them at this point. That is to say, they are touching each other externally at this point. Therefore, whenever you have an external notch between two circles, then the distance between their centers, that is to say BC, will be equal to the sum of the lengths of their radii. The radius of this circle is equal to 9 units. The radius of the smallest circle is equal to 1 unit. And the sum of the lengths of their radii is equal to 9 plus 1. That is to say, it equals to 10 units. So PE equals to BC equals to 10 units. So we copy the right triangle BQC in a new page, and we will implement the Pythagoras theorem on the right triangle BQC. So this is the right triangle BQC. First of all, we find out the value of side BQ. What is the value of BQ? You can see it easily from the drawing that BQ equals to BE minus QE. Again, BE minus QE equals to BQ. So I'll write it down. BQ equals to BE minus QE. So actually BQ is equal to BE, that is 9 units, that is the radius of the circle, minus QE. We already found out that QE equals to 1. So in conclusion, we found out that BQ equals to 9 minus 1 is 8. So BQ equals to 8 units. We can write here that BQ equals to 8 units. Now we can implement the Pythagoras theorem on the right triangle, triangle BQC. So on the right triangle, triangle BQC, according to the Pythagoras theorem, we get that BC square equals to BQ square plus QC square. So BC equals to 10. So BC square is 10 square. 10 square is 100. Equals to BQ square. BQ is 8. So BQ square is 8 square. 8 square is 64. Plus QC square. So QC square equals to 100 minus 64 is 36. We take a root out of this equation and we get that QC is equals to the square root of 36. The square root of 36 is 6. So I found out that QC equals to 6 units. You can write here also that QC equals to 6 units. We have already found out that QCEF is a rectangle. QCEF is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, QC is equal to EF. QC is equal to EF. But we have already just right now found out that QC equals to 6 units. So from this equation, 6 equals to QC equals to EF, we will conclude that EF is also equal to 6 units. So we can write here that EF equals to 6 units, and then also EF equals to 6 units. Okay? In the next step, we will draw a perpendicular from point C to OM. So this angle equals to 90 degrees, and this angle is also equals to 90 degrees. We will define the touching point between the perpendicular from point C to OM as U. Actually, quadrilateral UCMF is a rectangle because of the fact that it has 4 right angles. Okay, so quadrilateral UCMF is a rectangle and we know that the opposite sides of a rectangle are equal to each other. That is to say, CF equals to UM. CF equals to UM, but we know that CF is the radius of the smallest circle, that is to say it equals to 1 unit. So from this equation, 1 equals to CM equals to UM, we conclude that UM is also equals to 1 unit. So we can write here that UM equals to 1 unit. And likewise, UC will be equal to MF. UC will be equal to MF. But we know that MF equals to x plus 6. MF equals to x plus 6. So from this equation, UC equals to MF equals to x plus 6. We will conclude that UC is also equals to x plus 6. So UC equals to x plus 6. Okay? So in the next step, we will join points O and C together by a straight line. And we will implement the Pythagoras theorem on the right triangle, triangle OUC. We will implement the Pythagoras theorem on this right triangle, triangle OUC. So I will copy the right triangle, triangle OUC in a new page, and we will implement the Pythagoras theorem on this right triangle. But first of all, we'll find out the value of line segment OC. O is the center of the biggest circle, that is radius is equal to capital R. C is the center of the smallest circle, that is radius is equal to 1. the biggest circle and the smallest circle have an internal length between them at this point. That is to say, they are touching each other at this point. So whenever you have two circles that have an internal length between them, then the distance between the centers, it will be equal to the difference between the lengths of the radii. The length of the radius of the biggest circle is equal to capital R, the length of the radius of the smallest circle is equal to 1, and the difference between those two radii is equal to R minus 1. So, in conclusion, we found out that OC equals to capital R minus 1. And so here I copied the triangle OUC in a new page. We found out that OC equals to capital R minus 1. Here we already found out that UC equals to x plus 6. And what is the value of OU? The value of line segment OU. You can see it easily from the drawing that OU equals to OM minus UM. Again, OM minus UM equals to OU. So OU is equal to OM, that is Y, minus UM, that is 1. So we found out that OU equals to Y minus 1. Now we can implement the Pythagoras theorem on this right triangle, triangle OUC. Okay? So according to the Pythagoras theorem, in triangle OUC, we will get that the square of the hypotenuse, that is actually OC square. This will be equation number 3. OC square equals to the sum of the squares of the perpendiculars. That is to say, it will be equal to OU square plus UC square. So OC equals to R minus 1. OC square is R minus 1 square. And it equals to OU square. OU equals to Y minus 1, so OU square will be equal to Y minus 1 square plus UC square. UC equals to X plus 6. So UC square will be equal to X plus 6 square. So in conclusion, we found out that according to equation number 3, in the right triangle, triangle OUC, R minus 1 square equals to Y minus 1 square plus X plus 6 square. Here we will open the brackets on both sides of equation number 3, and we will get that according to equation number 3, R minus 1 square is r squared plus 1 plus 2r equals to y minus 1 squared. Y minus 1 squared is y squared plus 1 minus 2y plus x plus 6 squared equals to x squared plus 36 plus 12x here in equation number 3. We have 1 on both sides of the equation, so 1 will get cancelled. We will add 2r to this equation, equation number 3. And we get that according to equation number 3, r squared equals to 2r minus 2y plus 12x plus 36 plus x squared plus y squared. Here we subtract x squared and y squared from this equation, equation number 3, and we get that according to equation number 3, r squared minus x squared minus y squared is equal to, here we have 2r minus 2y, we'll take 2 as a common factor, and we get it that is equals to 2 times r minus y plus 12x plus 36. So we got the equation number 3 that states that r squared minus x squared minus y squared equals to 2 times r minus y plus 12x plus 36. And we have only found out that according to equation number 2, r squared minus x squared minus y squared equals to 18 times r minus y and according to equation number 1, we have already found out that r squared minus x squared minus y squared equals to 8 times r minus y plus 144 minus 24x. Here we create the question number 4 that states that r squared minus x squared minus y squared, according to equation number 1, that is equal to 8 times r minus y plus 144 minus 24x, it must be equal to r squared minus x squared minus y squared, according to equation number 2, that is equals to 18 times r minus y. Here we'll subtract 8 times r minus y from this equation, equation number 4, and we get that according to equation number 4, 144 minus 24x is equal to 10 times r minus y. Here we will divide the equation number 4 by 10, and we will get that r times r minus y is equal to 144 minus 24x over 10. Here we will divide both the numerator and the denominator of equation number 4 by 2. On this side of equation number 4, we will divide it by 2, and we will get that according to equation number 4, r minus y is equal to 144 over 2 is 72, minus 24x over 2 is minus 12x, and 10 over 2 is 5. So, in conclusion, we found out that r minus y, according to equation number 4, equals to 72 minus 12x over 5. Likewise, we create equation number 5 that states that r squared minus x squared minus y squared, according to equation number 2, that is equal to 18 times r minus y, must be equal to r squared minus x squared minus y squared, according to equation number 3, that it is equal to 2 times r minus y plus 12x plus 36. Here we will subtract 2 times r minus y from this equation, equation number 5, and we will get that according to equation number 5, 16 times r minus y equals to 12x plus 36. Here we will divide equation number 5 by 16, and we will get that according to equation number 5, r minus y is equal to 12x plus 36 over 16. Here we will divide both the numerator and the denominator of equation on three sides of equation number 5 by 4, and we will get that according to equation number 5, r minus y is equal to 12x over 4 is 3x, plus 36 over 4 is 9, over 16 over 4 is 4. But according to equation number 4, we've already found out that r minus y equals to 72 minus 12x over 5. In the next step, we create equation number 6 that states that r minus y, according to equation number 5, that is actually 3x plus 9 over 4, must be equal to r minus y, according to equation number 4, that is actually 72 minus 12x over 5. Here we cross multiply equation number 6, and we get that according to equation number 6, 5 times 3x plus 9 equals to 4 times 72 minus 12x. We will open the brackets on both sides of this equation, equation number 6. And we will get that according to equation number 6, 5 times 3x is 15x, plus 5 times 9 is 45, equals to 4 times 72, that is 188, minus 48x. Here we subtract 45 from this equation, equation number 6. 188 minus 45 is 243. It equals to 48x plus 15x is 63x. Here we will divide this equation, equation number 6, by 9. 63x over 9 is 7x. And 243 over 9 is 27. We will divide this equation, equation number 6, by 7, and we will get that according to equation number 6, x equals to 27 over 7. Now we will put the value of x inside the equation number 5. According to equation number 5, r minus y is equal to 12x plus 36. It's actually, according to equation number 5, we've already found out that r minus y is equal to 3x plus 9 over 4. So now we'll put the value of x inside equation number 5, and we'll get that r minus y equals to 3 times, and x is 27 over 7, plus 9 over 4. So according to equation number 5, r minus y is equal to 3 times 27 is 81, over 7, so we will multiply 9 by 7 and then we will divide it by 7 and we will get that it is equal to 63 all divided by 4, so we have found out that r minus y according to equation number 5 is equal to 81 plus 63 is 144 all divided by 7 times 4 is 28. Okay. Here we divide both the numerator and the denominator of this side of equation number 5 by 4 and we will get that 144 over 4 is 36 while 28 over 4 is 7. So actually in conclusion we found out that according to equation number 5 r minus y is equal to 36 over 7, while according to equation number 6 we found out that x equals to 27 over 7. We have equation number 2. According to equation number 2, r squared minus x squared minus y squared is equal to 18 times r minus y r squared minus y squared is r plus y times r minus y according to the algebraic identity that a squared minus b squared equals to a plus b times a minus b minus x squared equals to 18 times r minus y. We will add x squared to this equation, equation number 2, and we get that r plus y times r minus y equals to x squared plus 18 times r minus y. Here we will substitute r minus y by 36 over 7 and we will substitute x squared by 27 over 7 squared. We do it now and we will get that according to equation number 2, r plus y times r minus y is 36 over 7, that equals to x squared, x is 27 over 7, so x squared is 27 over 7 squared, plus 18 times r minus y is 36 over 7. Here we will multiply this equation, equation number 2 by 7, and we will get that according to equation number 2, r plus y times 36 equals to 27 times 27 over 7 plus 18 times 36. Here we will divide this equation, equation number 2 by 9. get that according to equation number 2, 4 times 36 over 9 is 4. So 4 times r plus y is equal to 27 over 9 is 3. So it is 3 times 27 over 7 plus 18 over 9 is 2, and 2 times 36 is 72. Here we multiply 72 by 7 and then we divide it by 7 in order to have a common factor with this expression. We will get that according to equation number 2, 4 times r plus y is equal to 3 times 27 is 81 over 7 plus 7 times 72 over 7. And we'll get that according to equation number 2, 4 times r plus y equals to 81 plus 7 times 72 is 504 over 7. 81 plus 504 is 585, and over 7, that equals to 4 times r plus y. We will divide this equation number 2 by 4, and we will get that r plus y is equal to 585 over 4 times 7 is 28. This is equation number 2, but we have already found out that according to equation number 5, r minus y is equal to 36 over 7. Here we will multiply both the numerator and the denominator of this side of equation number 5 by 4, and we will get that 36 times 4 is 144, and 7 times 4 is 28. So in conclusion, we found out that according to equation number 2, r plus y is equals to 585 over 28, while according to equation number 5, we've already found out that r minus y is equals to 144 over 28. So here we will add equation number 2 to equation number 5, and we will get that r plus r is 2r, and y plus minus y, it is actually equals to y minus y, because plus and minus is minus, so y minus y is 0. That equals to 585 plus 144 over 28. 585 plus 144 is 729 over 28. We will divide this equation by 2, and we will get r, the radius of the biggest circle that we are looking for, is equal to 729 over 56 units. Again, the radius of the biggest circle is equal to 729 over 56 units, so we can present it also as 13.018 units. So I write it down that the radius of the biggest circle is equal to 729 over 56 units, so we can present it also as 13.018 units. I repeat again, the radius of the biggest circle is equal to either 729 over 56 units, so you can represent it as also that it is equal to 13.018 units. In the next step, I will summarize the lecture. Actually, wanted to find out the radius of this circle, the radius of the biggest circle. We have here 3 circles that are located inside the biggest circle. We know that the radius of this circle is equal to 4 units, the radius of this circle is equal to 9 units, and the radius of the smallest circle is equal to 1 unit. And we want to find out the radius of the biggest circle that the 3 circles are located in. So first of all, I presented to you the theorem of internal notch. Whenever 2 circles are touching each other, they can touch it internally. Here, those 2 circles are touching each other internally, and the touching point is at point S. Point S is the point of tangency. And OM, the distance between their centers, is equal to capital R minus R. This is actually the difference between the radius of the biggest circle minus the radius of the smallest circle. So here, the distance between the centers is equal to the difference between the lengths of the radii. That is to say, in this case, it equals to capital R minus R. Okay. So this is the first type of tendency between 2 circles. The second type of tendency between 2 circles, when they are touching each other at one point, then they can touch each other externally. Here, the touching point is at point S. In this case, they are touching each other externally at point S, and so point S is the point of tendency, and the distance between their centers, that is to say MO, equals to the sum of the lengths of the radii. In this case, MO equals to capital R plus R. So those are the 2 types of tendency, the external lunge and the internal lunge. Okay? Then we defined the center of this circle as point A, we define the center of this circle as point B, and we define the center of the smallest circle as point C. We defined the point of tendency between the tangent and this circle as point D. We define the point of tendency between the tangent and this circle as point E, and we define the point of tendency between this tangent and the smallest circle as point F. Then we join together points A and D together by points A and D together by straight line. Actually, AD is the radius of this circle because of the fact that it starts from point the center of the circle and ends at point D. That is a point of this on this circle itself. We join points O, B and E together by a straight line. B is the radius, so here AD equals to 4 units, and here BE is the radius of this circle that equals to 9 units, and here CF is the radius of this circle that equals to 1 unit. Then I present to you a new rule number 1. According to rule number 1, the tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have the radius AD, it is drawn to the point of tendency. Therefore, the tangent FD will be perpendicular to AD. Why? Because of the fact that the radius is drawn to the point of tendency, that is to say, it is drawn to point D, that is the point of tendency of tangent FD with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent will be perpendicular to this radius. So here the tangent FD is perpendicular to this radius AD, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we have here the radius BE, it is drawn to the point of tendency, that is to say it is drawn to point E, that is the point of tendency of tangent FD with this circle. And because of the fact that the radius is drawn to the point of tendency, then the tangent FD will be perpendicular to this radius BE, that is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, the radius CF is drawn to the point of tendency, therefore the tangent FD will be perpendicular to this radius CF, that is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Then from point A we draw perpendicular to BE, so this angle is equal to 90 degrees, and this angle equals to 90 degrees, and we define the touching point between the perpendicular from point A and BE as P. Then actually quadrilateral APDE, in quadrilateral APDE we have 3 right angles, and the sum of 3 right angles is equal to 270 degrees. 270 degrees plus the size of the 4th angle, that is actually equal to angle DAP. In total, the sum of those 4 angles, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. We subtracted 90 degrees from this equation. We've subtracted 270 degrees from this equation, and we found out that angle DAP equals to 360 degrees minus 270 degrees is equal to 90 degrees, so this angle is a right angle. Therefore, quadrilateral ADPE is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, AD is equal to PE. But AD equals to 4 units. It is the radius of this circle. So from this equation, 4 equals to AD equals to PE, we will conclude that PE is also equals to 4 units. Then, what is the length of line segment BP? The length of line segment BP is equal to BE minus PE. Again, BP equals to BE minus PE. So BP equals to BE, that is 9, minus PE, that is 4. So in conclusion, we found out that BP equals to 9 minus 4, that is to say BP equals to 5 units. So we can write here that BP equals to 5 units. Then we focus on quadrilateral ASDM. In quadrilateral ASDM, we have 1, 2, 3 right angles, and the sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this angle, that is angle ASM. In total, the sum of those 4 angles must be equal to 360 degrees. We subtracted to 270 degrees from this equation, and we found out that angle ASM is equal to 90 degrees. So this angle is a right angle, and because of the fact that this is a right angle, then quadrilateral ASDM has 4 right angles, and because of the fact that quadrilateral ASDM has 4 right angles, quadrilateral ASDM is a rectangle. Then we focused on quadrilateral SPME. This quadrilateral has 3 right angles, and the sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this angle, that is angle PSM. In total, the sum of those 4 angles must be equal to 360 degrees. We subtracted 270 degrees from this equation, and we got that angle PSM, this angle PSM equals to 90 degrees, and because of the fact that quadrilateral PSME has 4 right angles, quadrilateral PSME is a rectangle. Okay, this is a rectangle. Then from point O we draw perpendicular to DE, so this angle equals to 90 degrees and this angle equals to 90 degrees. Actually, we know that when we define the touching point between the perpendicular from point O and DE is M, actually OM is a straight line. OM is perpendicular, it must be a straight line, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line OM at point S, then the sum of the angles must be equal to 180 degrees. Which angles we have at point S? We have here 90 degrees plus this angle that is actually angle OSA. In total, the sum of those 2 angles must be equal to 180 degrees. Okay, so 90 degrees plus angle OSA must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we got that angle OSA is equal to 90 degrees. Here, this angle is equal to 90 degrees, therefore triangle OSA is a right triangle. Then we join points A and B together by a straight line. And what is the value of line segment AB? A is the center of this circle that its radius is 4 units. B is the center of this circle that its radius is equal to 9 units. And those 2 circles have an external length between them, that is to say they are touching each other externally at this point. And whenever 2 circles are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of their radii. The radius of this circle is 4 units, the radius of this circle is 9 units, and the sum of the lengths of the radii is 4 plus 9. 4 plus 9 is 13, so we found out that AB equals to 13 units. Then we focused on the right triangle ABP, and we implemented the Pythagoras theorem on the right triangle ABP. According to the Pythagoras theorem, AB squared equals to PT squared plus AP squared. Again, in the right triangle ABP, AB squared equals to AP squared plus AP squared. AB is 13, therefore AB squared is 13 squared. 13 squared is 169. BP is equal to 5 units, so P squared is 5 squared. 5 squared is 25. So in conclusion, we found out that 169 equals to 25 plus AP squared. We subtracted 25 from this equation, and we found out that 169 minus 25 is 144. So we found out that AP squared equals to 144. We took a root out of this equation, and we found out that AP equals to the square root of 144. The square root of 144 is 12. So we found out that AP equals to 12 units. Then we have already found out that APDE is a rectangle. APDE is a rectangle, and in the rectangle APDE, the opposite sides are equal to each other. That is to say, AP equals to DE. AP equals to DE in rectangle APDE. But we just right now found out that AP equals to 12. So from this equation, 12 equals to AP equals to DE. We will conclude that DE is also equals to 12 units. So we can write here that DE equals to 12 units. And then we define line segment ME as X. That is to say, ME equals to X according to our definition. And then we have already found out that SPME is a rectangle, and the opposite sides of a rectangle are equal to each other. That is to say, ME equals to SP. ME equals to SP, but we have already found out that according to our definition, ME equals to X. So from this equation, X equals to ME equals to SP, we will conclude that SP is also equals to X. Here, SP also equals to X. Then we focus on rectangle ASDM. In rectangle ASDM, we know that AS equals to DM. But here, what is the value of DM? DM equals to DE minus ME. DE minus ME, it is actually equals to 12 minus X. So DM equals to 12 minus X. So in rectangle ASDM, the opposite sides are equal to each other. That is to say, AS equals to DM. AS equals to DM. But AS equals to 12 minus X, so but DM equals to 12 minus X, therefore AS will be also equal to 12 minus X. AS will be also equal to 12 minus X. And in rectangle ASDM, the opposite sides are equal to each other. That is to say, AS equals to SM. AS equals to SM, or AD equals to SM, but AD equals to 4 units, therefore SM will be also equal to 4 units. So SM equals to 4 units. And what is the value of OS? Here I copied the right triangle AOS in this new page. The right triangle AOS. What is the value of OS? OS equals to OM minus SM. OM equals to Y according to our definition. SM equals to 4. So in conclusion, we found out that OS equals to Y minus 4. We have already found out that AS equals to 12 minus X. And what is the value of OA? O is the center of the biggest circle that is radius is equal to capital R. A is the center of this circle that is its radius is equal to 4 units. Those two, the biggest circle and this circle, have an internal notch between them at this point, that is to say they are touching each other at this point. Therefore, whenever you have two circles that have an internal notch between them, then the distance between their centers, in this case is AO, will be equal to the difference between the lengths of their radii. The radius of the biggest circle is equal to capital R. The radius of this circle is equal to 4 units. And the difference between the radii will be equal to capital R minus 4. So in conclusion, we found out that AO equals to capital R minus 4. So now we can implement the Pythagoras theorem on the right green triangle, triangle AOS. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, AO square equals to OS square plus AS square. AO square equals to OS square plus AS square. AO equals to R minus 4, so AO square is equal to R minus 4 square. OS equals to Y minus 4. OS square, therefore OS square equals to Y minus 4 square plus AS. AS equals to 12 minus X, so AS square equals to 12 minus S square. So in conclusion, we found out that according to equation number 1, R minus 4 square equals to Y minus 4 square plus 12 minus X square. We open the brackets on both sides of equation number 1 here, and we got that according to equation number 1, here R minus 4 square is equal to R square plus 16 minus 8R, and it equals to Y minus 4 square. Y minus 4 square is equal to Y square plus 16 minus 8Y plus 12 minus X square. 12 minus X square equals to 12 square, that is 144, plus X square minus 24X. Here we added 8R to this equation number 1, and we got that R square equals to 8R minus 8Y plus 144 minus 24X plus X square plus Y square. We subtracted X square and Y square from this equation number 1, and we got that R square minus X square minus Y square equals to 8 times R minus Y, because here we took a common factor of 8, and 8R minus 8Y equals to 8 times R minus Y plus 144 minus 24X. So this is equation number 1. Then here we did a construction. From point O we go perpendicular to BE, so this angle equals to 90 degrees, this angle also equals to 90 degrees, and we defined the touching point between the perpendicular from point O to BE is point T. Then I copied the right triangle, triangle OBT in the new page, and we implemented the Pythagoras theorem on this right triangle, triangle OBT. So this is triangle OBT, and here we focus on quadrilateral OTME. Quadrilateral OTME has three right angles, 1, 2, 3. And the sum of three right angles is 270 degrees, so 270 degrees plus the size of this missing angle, angle MOT. In total, the sum of those four angles must be equal to 360 degrees. We subtracted 270 degrees from this equation and we found out that angle MOT equals to 90 degrees. Therefore, quadrilateral MOTO has four right angles. That is to say, quadrilateral MOTE is a rectangle. Okay? This quadrilateral is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to TE. MO equals to TE, but MO equals to Y according to our definition. So from this equation, Y equals to MO equals to TE, we will conclude that TE is also equals to Y. So here, TE is equal to Y, and we know that the opposite sides of rectangle MOTE are equal to each other. That is to say, ME is equals to TO, but ME equals to X according to our definition. So from this equation, X equals to ME equals to TO, we will conclude that TO is also equal to X. And what is the value of BT? BT equals to BE minus TE. Again, BT equals to BE minus TE. BE equals to 9. T equals to Y, so in conclusion we found out that BT equals to 9 minus Y, OB equals to Y minus 9, and OT equals to X. So now we can implement the Pythagoras theorem on this right green triangle, triangle OBT. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OB square equals to BT square plus OT square. OB equals to R minus 9, so OB square is R minus 9 square. That equals to BT square. BT is 9 minus Y, so BT square is 9 minus Y square. Plus OT square. OT is X, so OT square is X square. So in conclusion, we found out that according to equation number 2, R minus 9 square equals to 9 minus Y square plus X square. We open the brackets on both sides of this equation and we found out that according to equation number 2, R square minus X square minus Y square equals to 18 times R minus Y. Then from point C we draw perpendicular to BE, so this angle equals to 90 degrees and this angle will be also equal to 90 degrees. We define the touching point between the perpendicular from point C to BE as point Q. Okay, so here quadrilateral QCEF has 1, 2, 3 right angles, and the sum of three right angles is 270 degrees, so 270 degrees plus the size of angle QCF. In total, the sum of those four angles must be equal to 360 degrees. We subtracted 270 degrees from this equation and we got that angle QCF is equal to 90 degrees. Therefore, quadrilateral QCEF is a rectangle. This quadrilateral QCEF is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, QE is equal to CF, but CF equals to 1 unit. It is the radius of the smallest circle. So from this equation, QE equals to CF equals to 1, we will conclude that QE is also equals to 1. Okay? And we know that BE equals to 9 units. QE equals to 1. What is the value of BQ? BQ equals to BE minus QE. again, BQ equals to BE minus QE. So BQ equals to BE, that is 9, minus QE, that is 1. So BQ equals to 9 minus 1, 9 minus 1 is 8. So we found out that BQ equals to 8 units. And what is the value of BC? The value of line segment BC, B is the center of this circle, that its radius is equal to 9 units. C is the center of the smallest circle, that its radius is equal to 1 unit. Those two circles have an external length between them, that is to say they are touching each other externally at this point. So whenever two circles are touching each other externally, then the distance between their centers will be equal to the sum of the lengths of their radii. That is to say, we know that the radius of this circle is equal to 9 units, the radius of the smallest circle is equal to 1 unit, and the sum of the lengths of their radii will be equal to 9 plus 1. 9 plus 1 is 10. So we found out that BC, that is also the hypotenuse of the right triangle BQC, is equal to 10 units. We have already found out that BQ equals to 8 units. The missing side is QC, so we implemented the Pythagoras theorem on this right green triangle. Here BC square equals to BQ square plus QC square. BC is 10, so BC square is 10 square, 10 square is 100. BQ is 8, so BQ square is 8 square, 8 square is 64, plus QC square. So in conclusion, we found out that 100 equals to 64 plus QC square. We subtracted 64 from this equation, and we found out that QC square equals to 100 minus 64 is 36. We took a root of this equation and found out that QC equals to the square root of 36. The square root of 36 is 6. So we found out that QC equals to 6 units. And because of the fact that quadrilateral QCEF is a rectangle and the opposite sides of a rectangle are equal to each other, we will conclude that QC is equal to EF. But we just right now found out that QC equals to 6 units. So from this equation 6 equals to QC equals to EF, we will conclude that DEF is also equals to 6 units. So we can write here that EF equals to 6 units. And also we found out that QE is equal to 1 unit. Then from point C, we do perpendicular to OM. So this angle equals to 90 degrees and this angle also equals to 90 degrees. And we define the touching point between the perpendicular from point C to OM as point U. And actually copied the right triangle OUC in the new page, and we implemented the Pythagoras theorem on this green right triangle OUC. So here UCMF is a rectangle and the opposite sides of a rectangle are equal to each other. That is to say, UM is equal to CF, and we know that CF is equal to 1 unit. It is the radius of the smallest circle, so from this equation we will conclude that is also equal to 1 unit, and here we know that the opposite sides of the rectangle are equal to each other. That is to say, MF is equal to UC. UC equals to MF. But we already found out that MF equals to x plus 6. From this equation, UC equals to MF equals to x plus 6. We conclude that UC is also equals to M plus 6. UC equals to x plus 6. And here we know that equals to 1. So, and OM equals to y. So what will be the value of UO? UO or OU is equal to OM minus UM. Again, OU equals to OM minus UM. OM equals to Y. UM equals to 1. So OU equals to Y minus 1. So OU equals to Y minus 1. And what is the value of OC? We join points O and C together by a straight line here. What is the value of line segment OC? O is the center of the biggest circle that is radius with capital R. C is the center of the smallest circle that its radius is equal to 1. Those two circles have an external length between them at this point, that is to say, they are touching each other at this point. And any two circles that have an external length between them, then the distance between their centers will be equal to the difference between the lengths of their radii. The radius of the biggest circle is equal to capital R. The radius of the smallest circle is equal to 1. And the difference between the radii will be equal to capital R minus 1. So we found out that OC equals to R minus 1. We have already found out that UC equals to x plus 6. And OU equals to Y minus 1. So here we can implement the Pythagoras theorem on this right triangle, triangle OUC. According to the Pythagoras theorem, OC square equals to OU square plus UC square. So OC square is R minus 1 square, that equals to OU square, that is Y minus 1 square, plus UC square, that is X plus 6 square. So in conclusion, we found out that R minus 1 square, according to equation number 3, R minus 1 square equals to Y minus 1 square plus X plus 6 square. We solved equation number 3. And we got that according to equation number 3, R square minus X square minus Y square equals to 2 times R minus Y plus 12X plus 36. And we wrote down equation number 2 and equation number 1. Then we created equation number 3 that states that R square minus X square minus Y square according to equation number 1 must be equal to R square minus X square minus Y square according to equation number 2. And from equation number 4 we found out that R minus Y equals to 27 minus 72 minus 12x over 5. Then we created equation number 5 that states that R square minus X square minus Y square according to equation number 2 must be equal to R square minus X square minus Y square according to equation number 3. And from equation number 5 we got that R minus Y equals to 3x plus 9 over 4. We have already found out that according to equation number 4, R minus Y equals to 72 minus 12x over 5. Then we created equation number 6 that states that r minus y according to equation number 5 must be equal to r minus y according to equation number 4. And from equation number 6, we found out that x equals to 27 over 7. And according to equation number 5, r minus y equals to 3x plus 9 over 4. We put the value of x inside the equation number 5, and we found out that according to equation number 5, r minus y equals to 36 over 7. According to equation number 6, x equals to 27 over 7. Then we have equation number 2 that states that r squared minus x squared minus y squared equals to 18 times r minus y. We substituted r minus y by 36 over 7, and we substituted x by 27 over 7, and we found out that r minus y is equal to 144 over 28. R plus y is equal to 585 over 28. We added equation number 2 to equation number 5. So r plus r is 2r. Y plus minus y is y minus y, it is 0. So we found out that 2r equals to 585 plus 144 over 28. 585 plus 144 is 729. So in conclusion, we found out that 2r equals to 729 over 28. We divided this equation by 2, and we found out that r, the radius that they are looking for, that is to say, the radius of the biggest circle, equals to either 729 over 56 units, or we can present it also that the radius of the biggest circle is equal to 13.018 units. So I'll repeat again. The radius of the biggest circle is equal either to 729 over 56 units, or in terms of numbers, it equals to 13.018 units. Okay? Thank you very much.